Now we're going to jump quite a little ways because, as I said, folks, we're jumping time zones. And that's one of the great things about having a virtual conference like this. Now, this next gentleman I'm going to bring up on the stage, I got to tell you, you are, well, I'm just going to say you've got to get ready for this, because if you've been in the cleaning industry and you've been in the world of thinking you're doing something right, maybe you don't know all the details. I ran into this gentleman through where else but an online chat. We talked a little bit. He's been on our podcast, Beyond Clean with Ace. He talks, well, at a different level than what most of us are talking. So we're going to switch gears with you quite a bit. Not are we going to switch gears, we're going to switch continents. We're going to go all the way across the water, because where he's coming from, it's early morning the next day. Yeah, we're not talking about, a different time zone here. It's a completely different day. Well, who are we talking about? Where are we talking about? He's been talking with us, and he's been inspirational in our infection prevention courses. He is executive chairman of the Whiteley Corporation. He is an associate professor, a doctor, and I just have to throw this in, folks, because he also is a new father-in-law, which, if you understand what I'm talking about, he just got his daughter married, and he was really glad that we kind of moved this conference back a little bit so that he could participate. So, live from Sydney, Australia, it's Dr. Greg Whiteley. Now, I got to tell you, the title of his talk this afternoon, How Cleaning and Chemistry Assist Bacterial Biofilm Development. Now, I told you we're in for a treat. Dr. Greg, it's all yours.
Well, ladies and gentlemen, and Dave, thanks very much for having me on. I'm very deeply grateful for the opportunity to come and talk to you this afternoon. And yes, I am going to do a little bit of science for you, but we're going to keep it at a level that's quite easy to understand. And I'm going to talk to you about this thing called biofilms. Now, you've probably heard a lot about them, and my background, as Dave indicated, is strongly in the science, but also in manufacturing. My family has run a cleaning business or cleaning supply business, making janitorial chemicals and disinfectants for more than 50 years. We're a long-time member of the ISSA, and so I have a history steeped in the cleaning sector. And look, when we got into the sort of research that we're doing with biofilms these days, we were looking at cleaning, and we were particularly focused on cleaning endoscopes. One of the disinfectant groups that we're involved with is registered with the FDA, and we were having trouble getting endoscopes clean and ready for reuse. And what we found through a collaborative research program was that the endoscopes always seemed to have bacteria on them. Now, it turns out that the late Professor Bill Costerton had a daughter in Australia. He invented the term biofilms. Bill Costerton was a brilliant academic based up in Montana, Bozeman, Montana. And Bill basically observed that when bacteria move into a place, they start setting up home. Now, when I did microbiology as an undergraduate, as a freshman, we actually grew things in test tubes, and it was like sending the bacteria on holidays to the Caribbean. Everything was wonderful and warm, and there was lots of food, and there was breeding going on. But that's not how it happens in life. And Bill Costerton observed that the very first thing that happens, particularly in places like streams and at the intertidal zone at the sea, is that for things to attach onto the rock bed, the first thing you needed was bacterial growth. And the bacteria needed to create this thing called a biofilm. It was the bacteria making their own home. Now skip forward to us playing around with endoscopes. And we found that we could not get rid of persistent vegetative bacteria. In fact, our first paper in this area was in 1998, where we clearly published data showing that we could have a lot of trouble no matter what disinfectant you used. And we looked at glutaraldehyde, we looked at chlorine dioxide, we looked at peracetic acid. And it turned out the failure in every case was due to cleaning. So we started this fairly large program looking at endoscopes, which seems a long way away from the cleaning sector, I know. And endoscopes, of course, any body part that you've got that's got an orifice, a hole, you've got an endoscope we can stick into that hole with a telescope basically on it, a camera at the what we call the distal tip. And that camera can see into your body. But with the big scopes that go into your mouth or in your back passage, they're also hollow. They have tubes down the middle where you can flush water down, you can push down instruments on a long wire, you can do cutting and biopsies, and then you have to pull the sample back all the way through the tube. Well, those tubes get contaminated. And it's the inside that's difficult. Outside, well, you can give it a wipe. But what we found was that these channels were incredibly contaminated. And in fact, what we did was we learned that we could take the inside channel out of these endoscopes and replace it. So we did a deal with a local supplier, and they started giving us used endoscope channels. And we published in 1991 a paper that clearly showed that every single channel had evidence of biofilms. Now, we then published another paper, basically in the Journal of Hospital Infection, that made the point that biofilms were the big contributor to endoscope failure, cleaning failure. Now, skip ahead just a little ways, and about 5 years ago in the US, a new endoscope was produced by one of the big manufacturers, and at the very distal tip they had this very special type of camera for a procedure which is commonly called ERCP. Don't worry about all the detail. But this camera at the end folded back over on itself. And what we found, well, what the researchers found, after many patients had died, was the bacteria had got into that endoscope. It couldn't be cleaned. They grew resistant to disinfectants. They grew resistant to antibiotics, and they killed patients. Now, we moved after a fair while looking at endoscopes. Well, let me rephrase that. We still look at endoscopes cleaning. We still have a program looking at what bacteria live in endoscopes. Let me tell you, it's an absolute ecosystem. And what we found was that cleaning the channels turned out to be something a lot more challenging than we thought. And what we found was even the best of the enzyme cleaners only sheared off the top of the endoscope's biofilm. And the residual biofilm held onto superbugs. And the longer the bugs were in there, the more likely it is that the bugs became super resistant, not just to the disinfectants, but to antibiotics to which they were exposed. Now, we did solve that problem. We were the first to patent a technology that cleaned endoscopes and removed biofilms. That product is still on sale in the US in the medical marketplace. But we continued to look and see what else were these bacteria doing, because the real observation that we'd made was that these bacteria in wet environments became more resistant over time. And we wondered if that was part of the problem in the broader area of cleaning. And we went, it was our microbiologist's dream come true, and we went into an intensive care unit that was being decommissioned. They built a new one. So before they decommissioned it, they double disinfected and cleaned it with terminal disinfection using 1,000 milligrams per litre of available chlorine, parts per million is another way of saying that. They double disinfected it. We went in and we literally cut the ICU apart. And of course, what we found was that the bacteria and biofilms were basically on every major high-touch surface. The seminal paper was published in the Journal of Hospital Infection by Professor Karen Vickery, one of our long-term co-collaborators. And it revealed a number of things. The first thing is, it wasn't just one type of bacteria, just like we'd seen with endoscopes. There were multiple types of bacteria involved. Lots of different bugs. Golden staph or MRSA. There were VREs involved. There were an array of other gram-negative bacteria. And they were on places that had been disinfected. And yet when we went and looked at them under the microscope, what we found was that the biofilms, these dry surfaces, had significant biofilms. Now, they were very different from the surfaces of biofilms in endoscopes. So we had a hypothesis. What happens if all that is being done with the cleaning is the cleaners come in well-intended, well kitted out, but all they're doing is sloshing about detergent, a neutral detergent, and basically moving the dirt from one part to another part in the ICU, and literally just giving the biofilms a feed and a drink. And then when the chlorine came out, the bacteria hid inside their biofilm. And what we knew from other work was that the bacteria, once in their biofilm, were at least 200 times more resistant to disinfectants and antibiotics. So having made the observation that they were there, we put together a new program, and we realized the bugs are not transient, they're resident. So we set up a program to look at how could we reproduce in the laboratory what was going on in the real life world of an ICU. And what we found was two things. First thing is, the bacteria in those biofilms were in what's called a persister state. They could stay on that surface dormant for many years. Now, when I first started being involved in infection prevention, we used to have lists of how long different bugs survived. You know, Clostridium difficile or Clostridioides difficile lasted so long, and MRSA lasted so long, and norovirus lasted so long. We hadn't even heard of Candida auris at that stage. What we found, though, with the biofilm work was you needed to grow them in a different way. And once you grew them in a different way, allowing for these persister cells, you found that surfaces that you once thought were clean and sterile were actually still contaminated by resident bacteria buried in biofilms. So that was the first thing. They were persistent, they were resident, and they were still available. And the next thing that we found was that to grow them in the lab, we had to treat them a little bit different. Instead of treating them nicely, we had to do what happened in real world. That is, we grew them in a standard biofilm using the CDC biofilm reactor. But then we had to dehydrate them. We took them out, dried them out, left them on the bench, let them toughen up. Many of them died. But then we put them back into the growth media and grew them a bit longer. Then we pulled them out and dehydrated them again. And more died, but more survived. After 4 days, the biofilms in the lab suddenly resembled the dry surface biofilms we were seeing in the real world. Now, subsequent to that, we got back into hospitals, and what we found was that the biofilms, in fact, were everywhere. We published one paper in the American Journal of Infection Control that said finding the bad bugs in a busy ICU. And where were the bad bugs? They were on the sterile medicines trolley. They were on the crash cart for resuscitation. They were on the chairs and the desk and the telephones and the mouse pad and the E-key, enter key, on the keyboard at the nurse's workstation. And more work doing in this was done by a colleague of ours in Royal Prince Alfred Hospital in Sydney, where they tracked a VRE. So that's a bacteria that will live in your gut. It's multi-drug resistant. And if it gets into your bloodstream and you're susceptible, it has more than a 30% chance of killing you. Anyway, they were tracking this bug through this busy ICU. They did this across a 6-month period. And what they found, 3-month period. And what they found was they stopped their work in the middle and looked at all of the different high-touch surfaces in the ICU, supposedly they're being cleaned. The transfusion pumps, point of care equipment, the ultrasound device, the warmers. And they found that the VRE was all over these equipment. And what's more, it had then moved from these pieces of equipment into patients. and some of the patients died. Now, that set up a real problem for us. So we continued to work on our biofilms, and what we've been able to show is that once you're in these dry surface biofilms, these bacteria will not only resist standard autoclaving, but they will also resist hypochlorite up to 20,000 milligrams per litre. Now, a wonderful paper that was published in America was published by the team up in Cleveland under Professor Donsky. And he took a study where he said, well, normally we don't worry about the floors, but we're going to look at the floors in patient rooms with Clostridioides difficile and compare them to patient rooms where the patient does not have Clostridioides or C. diff. And they found a couple of things. First of all, the spores were on the floors of both rooms. But MRSA was 3 times more likely to be in the Clos diff patient rooms, and VRE was twice as likely. And that highlights the fact that while you're in there cleaning in these environments, the bacteria are always learning how to survive. And the ones that survive are the ones that can defeat their greatest enemy, which is antibiotics and chemistries. Now, Candida auris, which is obviously was becoming a big issue before COVID came along, turns out to be really difficult to kill. Guess what? Another biofilm former. And so whilst COVID only has a very small risk of being caught via surfaces, all of these other bacteria are resident on surfaces and pose risk to patients. And what we found is that poor cleaning, which has got many, many variables involved, is the easiest way to move these bugs from place to place, surface to surface, and poorly used disinfectants, poorly used technique will actually help the bugs to survive. In fact, we've now shown and published that whereas a standard bacterial colony will be removed with 1 wipe, even after 50 wipes, biofilms will not be removed. This is a big challenge for cleaning. It's a big challenge for all of us. And as we move out of COVID and back into the period of the superbugs, we're all, as cleaning and cleaning suppliers, right in the centre of the storm once again to try and solve the problem and defeat the biofilms that are trying to defeat us. Thank you very much.